In last period, we have discussed that which are the angles formed by the transversal to the given two lines. Now here special lines we have taken, that is L and M are the parallel lines and T is the transversal. Then what is the special properties that the angles whatever form have some special properties that we discuss here, and that you already learnt in the 7th standard, but in 9th standard you are going to prove that all the properties. The first of all, there is one axiom related with the corresponding angle. Now first of all, identify the corresponding angles in this diagram. Corresponding angles are 1, 5, then 4, 8. Okay, that is corresponding angle where I am writing angle 1, angle 5, angle 4, angle 8. Now another pair, angle 2, angle 6. Okay, this one. Now angle 3 and angle 7. Angle 3, angle 7. The corresponding angle formed by the transversal to the parallel line are always equal. Means the pair of corresponding angles are equal when the transversal intersect to parallel line. This is the one of the axiom, that is the universal truth. We have to take as it is, and it is the universal truth. Means if the lines are parallel, there are two axioms. If the given lines are parallel, then the pair of corresponding angle, each pair of corresponding angle is equal. And converse of this axiom is, if the transversal intersecting two lines and the pair of corresponding angles are equal, then that given two lines are parallel. Means if the line is transversal intersecting to any two lines and corresponding angles are equal, suppose A, B, C, D, means A is equal to B, C is equal to D. These are the corresponding angles. If these two angles are, the pair of each corresponding angle is equal, then you can directly say that given line, suppose this is S and T, these two lines are parallel. And one axiom is, if the two lines are parallel, means given that the lines are parallel, then you can directly say that the corresponding angle, each pair of corresponding angle is equal. These are the two axioms that you have to write, and thoroughly you have to go through it. Okay, by using this axiom, we are going to prove the theorems, alternate angle theorem, co-interior angle theorem, and their converse. First of all, we will discuss what are that only just by using the diagram. Now, what is the property? Alternate angle, exterior alternate angle. Which are the exterior alternate angle and interior? Now, 4, 6 and 4. This is the interior alternate angle, and 3 and 5. 3 and 5 are the interior alternate angle. They are also equal when the lines are parallel. Means angle 4 is equal to angle 6 and angle 3 these are the exterior. Here I have to write. Okay, interior, that is angle 4 equal to angle 6 and angle 3 equal to angle 5. Like that, exterior alternate angles are also equal. Pair of exterior angle. Pair is this 1 and 7. Angle 1 is equal to angle 7 and angle 2 is equal to angle 8. That we are going to prove, but we are revising the property which we want to prove. Now, what is the property about the co-interior angle when lines are parallel? Now, which are the co-interior angle? These are angle 5 and angle 4 are the co-interior angle, as well as angle 6. Angle 6 and angle 3 are the co-interior angle. The co-interior angle formed by the transversal to the parallel lines are supplementary. What is meant by supplementary? Means their sum is equal to 180. What is the property of co-interior angles formed by the transversal to the parallel lines is angle 4 plus angle 5, as angle 4 and 5 are co-interior, equal to 180. In other words, you can say they are supplementary. Another pair is 3 and 6. Therefore, angle 3 plus angle 6 is 180 degree. Now we are going to prove this. This we have to taken as axiom. By taking the its support, we are going to prove this all the theorems and their converse. Good afternoon, children. Today in this video we are going to discuss some theorem. We are going to prove some theorem. For that there are two axioms that are the universal truth, which are we are going to use. If a transversal intersects two parallel lines, then each pair of corresponding angle is equal. Means what is given? If the lines are given parallel, then their corresponding angles are equal. This is the axiom that we need not to prove. And converse of it is the axiom second. And this both the axiom together are called as a corresponding angle axiom. So if a transversal intersect two lines, two lines are given and one transversal intersecting them, making a pair of equal corresponding angle. Means if the transversal intersect them, and if the pair of corresponding angle equal, means the corresponding angles are given equal, that means that given two lines are parallel. Means if you want to prove the lines parallel, what you have to prove? You have to prove that their corresponding angles are equal. And if lines are parallel, then you directly say that the corresponding angles are equal. By using these two axioms and vertically opposite angle theorem, which we have seen previously, we are going to prove the theorem that is called as a alternate angle theorem. Let us revise one the statement. If a transversal intersect two parallel lines, if transversal intersect two parallel lines, means what is given? The lines are parallel, that is given to you. Then means whatever the statement given after the then, that you have to prove. That is, each pair of alternate interior angles are equal. First we are proving the interior and alternate angles are equal. Now with this statement you have to draw the diagram and write given to prove and then prove. Okay. Now what is given? Lines are parallel, that is line L is parallel to M, and one transversal is intersecting these two parallel lines. Okay. Now what is given according to the statement of the theorem? That is line L parallel to line M. This is the symbol of parallel lines. And suppose T is the transversal and T is transversal. This is given to you. Now what to prove? Systematic manner you have to write. What to prove? You have to prove the alternate angle, interior alternate angle. Means this angle is equal to this, we will give the name, that is 1, and this one angle, let us take 2, 3, 4. Whatever the equal symbolically I represented, what we have to prove? We have to prove that angle 1 equal to angle 3. Angle 1 equal to angle 3 we have to prove, as well as angle 2 equal to angle 4. That you have to prove. Now to prove this, we have the axioms that we are going to use. Let us see the proof. Now how to prove? Now what is given? Lines are parallel. Means the corresponding angles are equal. Which are the corresponding angle? Now for the 3, which will be the corresponding angle? This one. So name it as a 5, because 4 angles we have taken. Okay. Now this. Now angle 3 is equal to angle 4. Why? By the axiom angle 5 is equal to angle 3. Why? because these are the corresponding angle and these lines are given parallel. Therefore, angle phi equal to angle 3. What is corresponding angle? That reasons you have to write. Okay. Now, also you know that angle phi equal to angle 1. Angle phi equal to angle 1. What is the reason? Because these are the vertically opposite angles, as T and L are two lines and intersecting at this point. Okay. Therefore, this is vertically opposite angles are equal. Now, from these two equations, angle phi equal to angle 3, angle phi also equal to the angle 1. That means, this implies that angle 3 equal to angle 1, and that only we have to prove. But this is in short you are writing. This you can write for the 2 mark or 1 mark. But whenever they are asking for the 3 mark, just try to write the names in the 3 letters. So I am giving this line as AB, this is CD, and these 2 points are P and Q. Okay. Now write this letter's name in roughly you can do, and write this angle's name in the 3 letters. What is the angle phi? I am writing in brief now. Okay. Angle phi is angle. Here you have to give the name again. Suppose R and L. This angle phi. What is the name of angle phi? Angle PRPB. Angle RPB is equal to angle PQD. PQD. Again, reason that is I am writing these only in the 3 letters. Okay. Again, angle phi. Angle phi is again angle RPB is equal to angle 1. What is the name in 3 letter? APQ. Angle APQ. Therefore, as RPB is equal to this 2. Therefore, these 2 sides you can equate. That is angle PQD is equal to angle APQ. Do the practice of writing in these 3 letters. This is and this is are the same, but I have written this in the properly in the geometrical way. So you have proved that this case. Now you need not to prove it again for this. Okay, you can write similarly. We can prove that angle 2 is equal to angle 4. In same way you can prove. Okay. Now in 3 letters we are going to write the angle 2. Angle 2 is BPQ. Angle BPQ. Angle 4 is angle PQC. Angle PQC. And that's how we have proved the alternate angle theorem. What is alternate angle theorem? Lines are given parallel and you have to prove that interior alternate angles are equal. Means 3 angle 1 is equal to angle 3, angle 2 is equal to angle 4. And given is lines are parallel. So in this way you are going to write. Next converse of it we are here.